Hello students, myself Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now, we are going to discuss about fiber to fiber connection. First of all, we should understand why this fiber joint required. So, we know that in optical fiber communication, here we can transmit a light signal into the fiber. Practically, the manufacturing of fiber around 10 kilometers, 20 kilometers is not possible. So, maximum you can manufacture only 50 meters to 100 meters only. So, we need to join a two fiber. That is very important in optical fiber communication system. Another case, if any damage occurs in the fiber, so we need to cut the fiber, we have to rectify the problem. After that, we need to join the two fiber. So, this is one of the important points why you can go for fiber joint. Next one, suppose I want to test some equipment. So, at that purpose also we need to cut the fiber, test all the equipment. After that, we have to rejoin the fiber. So these are the important points why the fiber joint required in optical fiber communication system. Now, if you join the two fiber, we have to see the important point is the coupling efficiency. How the source and the optical fiber, these two are coupled each other. This is important. So, the efficiency may be calculated, the power coupled into the fiber by the power emitted from the source. If you join the source with the fiber or if you join a fiber to fiber, so you have to find this efficiency. This efficiency is very, very important. How much light signal can be transferred from fiber 1 to fiber 2? Suppose, let us assume, so now the fiber here, suppose for example, this is a source and this is optical fiber. The efficiency may be calculated by power coupled into the fiber by the power emitted from the source. Simply we can call PF by PS. So, it gives a coupling efficiency. While for fiber to fiber communication also same thing, the power coupled into the fiber 1 by power coupled into the fiber 2, like that. So, here this efficiency is very, very important while calculating the coupling efficiency, because how much power can be successfully transferred from one fiber to another fiber. This is very, very important. Good. Next, fiber to fiber connection. So, coming to the fiber to fiber connections, so we are facing these four problems while connecting the two fibers. One is lateral misalignment, axial separation, angular misalignment and rough end. So, these are the problems we are facing while joining a two fibers. Let us see one by one. Lateral misalignment. Here, come to the lateral misalignment. So, it is a failure of cross section of the two fiber cores to perfectly overlap. If you see, this is the fiber 1, this is a fiber 2. If you observe the diagram, see the amount of signal in the fiber 1 is totally deviated. Only 50% of the amount of signal only enter into the fiber 2. So, here we are experiencing the loss of power. So, due to the misalignment of the fiber joint. Now, this can be calculated by using the formula. So, efficiency eta is equal to 2 by pi cos inverse of d by 2a minus d by 2a of root of 1 minus d by 2a whole square. So, what is the d? The d is nothing but the axis of the two fibers are separated by the distance d. If you observe this diagram, see, so this is nothing but the d, where a is nothing but the radius of the fibers. A is nothing but the radius of the fiber. So, if you observe, see here when the fiber is perfectly matched, then this both the circles are overlap perfectly. Okay. If you observe this overlapping thing, so here, so this is nothing but the misalignment area. Here only we are experiencing the fiber loss. Next one, axial separation. This is another important loss in the fiber to fiber connection. Here, what is the fiber to axial separation is nothing but, here these two fiber may not contact with each other. We are supposed to think these two fibers are join each other, but if you see when the end surface, the two fiber do not come into the contact with each other. This is the thing with the axial separation. Even a slight gap also creates a more loss. The slight separation will generally be design the device so that the fiber are not damaged but butting against each other. So this cause the axial separation. So here also we are experiencing a more loss. The loss may be calculated. So loss L is equal to minus 10 log of 1 minus x NA by 4A N naught, where NA is nothing but the numerical aperture, the x is nothing but the axial separation distance, and the A is nothing but the radius of the core, and the N naught is nothing but the refractive index of the air medium. So here, while calculating this loss, so these are the parameters required. So these are the parameters influencing the loss. Next one, another important misalignment is nothing but angular misalignment. So what is the angular misalignment? Here, one end of the fiber is perfectly somewhat joined, but another end is so open. So this will create a significant loss. See here, the misalignment generally does not contribute significantly to connection, but because of the manufacturing tolerance, so this eliminate the misalignment in connectors and splices. So this loss also we can experience more power loss. Okay. So this efficiency may be calculated. Eta is equal to 1 minus, here also N naught is there, this N naught is nothing but the refractive index of the air medium, this theta is nothing but the angular, the angle of the two fiber, then divide by pi into Na. Okay. So this here by using this efficiency formula we can calculate the angular misalignment losses. Next one, rough end. Here generally this rough end, here many optical fiber communication system were installing the two fibers. Here most of the technical people are experiencing this kind of losses in the rough end. While cutting the two fiber, it should be a smooth end here, but suppose for example, if the fiber end is smooth, no problem, it will join. Suppose a fiber end is like this, we are unable to join the two fibers. So this is nothing but the rough end. Here we need to make smooth end and then you can join, but some cases, so due to this rough end of the fiber, we are unable to join the fiber properly. So what will happen? So in this gap, so the losses may be occur, the power may be lost. The power may be lost in the sense the amount of light in the fiber 1 is not equal to amount of light in the fiber 2. See, the loss when transmitting a fiber core at radius A1 to having the core A2. So here we are experiencing the more loss. So this maximum, here we can call it a scattering from rough end phase would cause more loss. So this is one of the important thing in the optical fiber communication. So we are facing, so the four main joints problem. One is lateral misalignment and angular misalignment, axial separations and rough end. So these are the four major drawbacks while joining a two fiber. Thank you.